Okie dokie. So, this should be a relatively quick set of notes on renewable and non renewable resources. Quick note that this is focusing on energy resources. So, first, let's talk about non renewable energy sources. What are they? They are energy sources that exist in a fixed or limited amount. What that means is that they can't easily be replaced, which means we will run out of them. Now, it may not be within your lifetime or my lifetime. It may be 100, 200 years from now, but eventually we will run out of them, which means that we're going to have to, at some point, adjust our society to be able to use other alternate sources of energy. So, this is the way I think about it. We have the Earth. Let's imagine that all these bricks represent the coal supply found on Earth. This is all we've got. The Earth is not generating more. And as we continue to use it, we end up having less and less of it available. No more is being generated. And so eventually, we will use up what we have on the Earth. So, some examples fossil fuels are the big example most people think of. They tend to form under very specific conditions, and they take hundreds of millions of years to form, anywhere between 200 and 300 million years. Unfortunately, a lot of the sources that are very easy to reach, that are closer to the surface, have already been used up, which means that it's going to be more expensive and take more energy to get to these sources of energy. Nuclear power is not always lumped in with the non renewable energy sources, but technically it is non renewable because you need a specific fuel source for it. That is uranium and plutonium, which are radioactive elements. There is a fixed amount of uranium and plutonium on Earth, and we really can't create more. Honestly, the major way that uranium and plutonium are made are mostly in stars. And, that's kind of hard for us to reproduce. Unfortunately, once we get past using up the easily accessible sources of those radioactive elements, the best option we would have would be to maybe get them from outer space. However, that would be very expensive and very difficult to do. So we shouldn't count on that in the near future. This leads to a concept called a reserve. A reserve represents how much of a resource is economically feasible or economically convenient to extract. How much of it can we get out without spending way too much money and way too much energy to get it out? So that's what this chart shows you. You can think of it as the number of years of a resource we have left. And keep in mind ooh, that's supposed to be an at symbol, current rates of use. So that means if we suddenly start using a lot more of it, we may have a smaller reserve than originally indicated on this graph or in other estimates. And if we start using less of it, we may be able to expand our reserve. Not because we'll find new sources, but just because we're not using as much of it. So it should last a little longer. So, an example, at the current rates at which we use it, we have about 50 years of oil left, about 50 years of natural gas from non renewable sources. Natural gas is a weird one. We can actually produce more of it. We'll talk about that later. Uranium, which is the major fuel source for nuclear power, we have 90 years of it. And coal, we do have 150 years of it left. But as we are going to talk about, it is a major environmental problem to use coal. So, if you're thinking about this, if you look at this diagram, which shows you two different types of coal deposits, which are represented by the black smudges. So that would be coal and that would be coal as well. Which of these would be more economically feasible to get to? Well, obviously, the surface mine would be easier to get to because, you spend less energy, less money getting to it. However, we've run out of a lot of the sources of surface deposits of fossil fuels and uranium. So now we have to go for deeper sources like these subsurface areas. And that means it's going to get more expensive and more difficult to get these non renewable resources out of the ground. What does that mean? That means that we're going to have to adapt to use more renewable energy sources because they are replaceable. We can get more of them. So these can be replaced or replenished, and that happens naturally. We can also produce more of it in the case of natural gas. And here is a key point. It needs to be at or near the rate at which we consume it. If we use it up faster than it's remade, then it's not going to be renewable for very long because we can then use up what supply we have. So, some examples of this are solar power. Big example of solar power is solar panels, hydroelectric power, which uses hydroelectric dams on rivers, wind power, which uses wind turbines, geothermal energy, which uses an underground heat source near areas where there's a lot of tectonic or volcanic activity to produce power, biomass, which is usually burning organic material like plant waste or even wood. And hydrogen fuel cells, which use hydrogen gas and oxygen gas to produce energy. We're going to talk about each of these in more detail in future sets of notes. So that is that, and on to the next set.